Hi folks, in this first video we're going to see how we can use ray diagrams to find the image of a point in a plane mirror. Okay, now if you consider this point and this being your plane mirror, we already know where this reflection should be located. Okay, it should appear behind the mirror at the same distance as the object is to the mirror. But if we want to demonstrate that using ray diagrams, okay, we have to use our laws of reflection. Okay, so I would say the easiest ray to start off with is one that hits the mirror at 90 degrees. Okay, because it's going to be going along the normal, so it's just going to bounce right back out. Okay, so what you want to do is you want to try to be as precise as possible. So what you want to do is take your protractor and make sure that you're lined up exactly at 90 degrees. Okay, so there's the 90-degree mark, and now from here you can draw your ray. Okay, notice I try to go through the center of the circle, so there's my ray going in that direction. Okay, and it's going to bounce right back out, but we know that the image is going to appear behind the mirror. Okay, so what we can do is we can continue this line because that's where the intersection of our rays are going to be. Okay, so there's one ray. Okay, so now what we'll do is I'll normally ask you for only two. I'm going to draw three here. So here I can draw a ray to any point on the mirror. Okay, there's our second incident ray. And again, if I want to determine the reflected ray, now I'm going to need to draw the normal. So again, I go to the point where the ray hits the mirror. I try to get that intersection right. Okay, try to line it up perfectly with the line. Okay, and now I'll indicate my normal. Okay, sorry about that. So here's my normal. Okay, and what I need to do is draw a ray that's the same angle as the incident ray. Okay, so here, there we go, line everything up. And I see here that my incident ray seems to be about 10, maybe 15, looks to be about 16 degrees. Okay, so I'm going to draw my reflected ray 16 degrees away. So this is 10 degrees and it's about 16, so I'll mark it there. And so here's my reflected ray. Okay, going outwards. But of course we know that that might appear as though it's coming from behind the mirror, so I can extend that line. Okay, and this point we see is where they intersect. Okay, so normally I'd be happy with just these two rays, but just to do try to be a little more precise, I'm going to draw a third ray. So let's draw one to the bottom here. Okay, so I draw my incident ray. Okay, oops, it's going in that direction. Okay, and now I'm going to use my protractor here. Okay, and this time I'm going to save myself a bit of time because I know that my normal is here, and I look at my incident ray, okay, which is this one here. It's 10, 20, 30, and it looks to be about, okay, if I extend that line, looks to be about 35. Okay, so get this back, 10, 20, 35. There we go. So there's my reflected ray. Let's get that nicely there. There's my reflected ray, and if I continue it all the way back, I see it intersects pretty much as the same point as before. Okay, so there's my reflected ray. Okay, and if I do want to confirm what we know about reflections in plane mirrors, I can measure here, and it should be the same distance away. So 1, 2, 3.6 centimeters, and here we have 1, 2, 3. Well, it looks to be about 3.7. So that's pretty close. Okay, given that we're doing this by hand, it won't be perfect. Okay, so if you're trying to demonstrate where the reflection of a point in a plane mirror would be, this is how you would do that. I would ask you to use two rays, even though I did three. I would definitely use the ray that goes directly to the mirror at 90 degrees. Okay, make sure you're using your protractor for that. And then once you draw your second ray, you have to first determine the normal and then make sure that the incident angle is equal to the reflected angle.